At 11 p.m., the substrate of this tank turns into a parking lot. Search Malaysian trumpet snail, and the internet agrees on one thing: get rid of them. Not many buy these on purpose. They arrive stowed away in plant shipments, and within a season they own the tank floor. This episode isn't going to talk you out of that reaction. It's going to explain why that reaction is aimed at the wrong problem. Melanoides tuberculata. The shell is a tapered spiral with countable whorls banded brown and olive. The operculum is a hardened plate on the foot. Withdraw the animal and it seals the opening completely. A trap door, a method of protection from the elements and would-be predators. Native range spans freshwater and brackish habitats across Africa, the Middle East, and South and Southeast Asia. Everywhere else, it arrived by accident. Just behind the head, underneath the shell, is a brood pouch. Malaysian trumpet snails carry developing young inside it and release them as miniature adults. A single individual, with no mate present, is enough to found a population. Most captive populations reproduce by parthenogenesis, cloning without fertilization. That's the whole reason for panic, in one sentence. Populations aren't strictly clonal. In native range populations, in Africa, the Middle East, and Asia, males do exist, and sexual reproduction happens. Nearly every population outside that range, however, including the ones sold through the aquarium trade, are functionally female. What raises male frequency in a given population is still unresolved. The leading hypothesis, that parasite pressure favors sex, was tested directly against wild populations and didn't hold. Male frequency showed no correlation with the infection rate. So no, bad water or crowding will not summon them. Telling them apart by eye doesn't really work either. Theorids have no external copulatory organ to spot, so sex is normally confirmed by examining the gonad directly. One study even ran a full shell-shaped statistic on a population just to sort specimens reliably. That's the level of effort it takes to sex a snail with a trap door. The young hatch as fully formed snails, all ready to burrow. In the early stages of colonization, you may not even realize the snails are present. During the day, most of the population is under the substrate, not on top of it. They surface after the lights go out. Each pass through the substrate turns over a small channel of material, pulling trapped gas and waste towards the surface. That gas could be hydrogen sulfide. Undisturbed, the substrate develops anaerobic pockets. Left long enough, these pockets release hydrogen sulfide when finally exposed. That rotten egg after a deep vacuum. A tank with an active trumpet snail population rarely builds that pocket in the first place because something is turning the substrate over every night. These snails also work the detritus from the surface of the substrate into the deeper layers on their return to their daytime refuges. This process of living things moving sediments is known as bioturbation, an act with deep value for your tank. Populations that explode also stop exploding. With a fixed food supply, growth follows a logistic curve, not the previous exponential one. Fast rise, then a ceiling, set by what's available to eat, not by any built-in restraints. That ceiling is density dependent. More snails competing for the same detritus means less food per snail. Reproduction slows, mortality rises, until births and deaths roughly balance. Carrying capacity in real time in a glass box. Which puts the population itself to work as an instrument. A sudden boom Dozens of new shells appearing week over week usually means excess food, consistent overfeeding, or a bioload the filter isn't keeping up with. A population that crashes or disappears means the opposite. The substrate has been vacuumed too aggressively. Perhaps there's too little organic matter and there's nothing left to eat. Population size is one instrument. The shell itself is another one. A healthy-looking shell holds a defined, pointed apex and a smooth outer layer. An eroding apex, one that's chalky, pitted, sometimes worn down to a blunt stub, reads the same signal found on the ramshorn snails. Low pH, low GH, perhaps both. That's the tank pulling calcium carbonate out of the shell to buffer the water. Growth bands, ridges circling each whorl, mark points where growth paused. A cold snap, a missed remineralization. A stretch, the tank went completely untouched. A stable, moderate population on a smooth, unpitted shell is what a properly balanced substrate and water column look like. The one outcome nobody posts about because it isn't a problem. None of the previous applies outside of the tank. Melanoides tuberculata is established in warm springs across both Florida and Texas, introduced through the aquarium and aquaculture trade. In those systems, it competes directly with native snails for the same detritus it processes so efficiently in captivity, and in several documented cases, it has displaced those native snails. The same trait, useful in a closed tank, is a liability in an open watershed, which is the actual rule, not the exception. Nothing in this tank goes down the drain that leads outside. This species least of all. That same competitive edge has also been used on purpose. In the Caribbean and parts of Brazil, public health programs introduced this species specifically to displace Bionflaria snails, the species that transmit schizomyces. In 2 lakes near Belo Horizonte, the target snails were gone within 8 years. The detritus episode covered what happens to a leaf after it falls. The shredders episode covered who tears it apart first. This is what happens underneath all of that. After both of those steps are done, the part of the food web operating below the substrate line, largely unwatched, entirely unpaid. Leave them in the tank. Examine the amount of excess food you're feeding instead.